Hello and good afternoon, everybody, to the Dlubal Webinar about RFEM and design in steel structures. I'd like to welcome you this afternoon to this first webinar we're doing from Dlubal Engineering Software, and my name is Walter Rustler, together with Chelsea Jennings, my colleague from support, will do this presentation today. Before we start the actual presentation of the software, I'd like to go through with you the content of this webinar for the next 30 to 45 minutes. And we will start with a short overview about the Dlubal company itself. And I will give you a short introduction into the overall architecture of RFEM. Then we will follow with the actual presentation of the software itself, and at the end we will have time for some additional questions that we can answer. First we will start with the overview to Dlubal software, and I'd like to show you just a few slides about Dlubal software itself. The company is actually a German company that is located with offices in Leipzig and in Tiefenbach, and we are also having an office in Prague in Czech Republic, where we do the developing, or most of the developing, of the software. We have customers all over the world and employ altogether about 150 engineers and programmers. And within the 20 years we are in the market, we have gathered customers in all major countries of the globe, and we are happy to have about 7,000 users that are working with our software. Our two main products are RSTAB and RFEM. RSTAB is a pure framework program that only covers member-based structures like columns and beams, while RFEM is a more complete package that includes also surfaces for slabs or walls, or solid elements and special features like contact elements. So it is more powerful and more sophisticated, but they share the same user interface. So once you are familiar with one product, you can easily work with the other one, and vice versa. Both products are equipped with additional modules. Some of them we will see today. So you can tailor the package to your needs. And as I said, they share the same user interface, so it's no big problem to change from one product to the other one. The calculation cores of both products are different, so you also have the option to verify, for example, a RSTAB calculation inside RFEM. And the calculation cores include different theoretical backgrounds, so there is some smaller differences, but the results should be more or less the same. For today's webinar, I'd like to introduce Chelsea Jennings, my colleague. She is doing the presentation in RFEM, and after a few seconds I will hand over the control to her. We'll show the modeling and analyzing of steel structures within RFEM on the example of a small model, so you see the principles how to work with our software. Maybe some more organizational things. You can show and hide the control panel that you see on your screen with by clicking on the red arrow. If you have some questions, you can use the questions chat option where you can type in your questions. And at the end of this webinar, we will go through those questions and we'll present answers to them. If we can handle all of them, we will do all of them. More information about Dlubal and the products in general you can find, of course, on our website, www.dlubal.com. You can also follow us on Facebook and Google+. You find videos in YouTube, and for those who are active in networks like Xing or LinkedIn, you will also find us there as well. In those social networks, we will provide newest information, news channels, events, videos. Will be posted there. In any case, you are welcome to email us or call us with any question. Just go to our website. You find all the contact information there, and we are happy to answer your questions. For more information, especially also on upcoming webinars, I'd like to point out one more page on our website. It's www.dlubal.com webinars.rspx. Here you'll find all scheduled webinars, upcoming webinars, and the next one will be on March 13th, and it will be about modeling and analyzing concrete structures within RFEM. This is it for the first short introduction, and now I'm moving on to the RFEM program itself, and I'd like to show you the overall concept of the software. RFEM is a plain, it's a common Windows application that has typical objects like menu bars and toolbars, but it has more things that we use while we are modeling and work with our structures. It has the workspace where you can rotate and zoom in and zoom out. The graphical workspace is actually where we do most of our modeling, so it's a graphical driven user interface. Then we have the navigation trees to the left, and those are divided in several parts. One is the data tree, where all the data will be filled in during the work with the model. For example, it's a very important order or part of the architecture is we grouped everything into structural data, loads, results, and then some other additional groups like guiding objects, printout reports, and then, which is also very important, the additional modules. Everything inside RFEM, everything what is inside RFEM is the modeling, graphical, numerical, the load input, the analysis of the internal forces and deformation, support reactions, and then with the design into different materials, for different materials you get into additional modules. For example, you can buy different modules for concrete design, for steel design, for timber design, or additional modules for earthquake design. So you can tailor actually your program as you need it, and you don't have to buy the full package. You can start with a smaller version and upgrade gradually whatever project you are going to work on, and this way buy only the parts that you need. You can see we have a variety of modules that cover timber, steel, and concrete, but also materials like glass or tower structures are possible, or we have a variety of modules for connection design. So we maybe direct you to our website where you can also download a demo version of it, of the whole program, if you're not already using it and are familiar with it. So the navigation tree is one important thing that we are going to use during the presentation, of course, and we can control here also actually in the display tree what we will see, what parts we will see. We can hide different sections, different parts of the structure, and change things like display numbering and so on. Similar or also very important and powerful tool is are the tables that are located usually below the workspace, and they follow the same order from nodes, lines, materials as the data tree. It's all resembling in the same order here, and you kind of work your way either from top to bottom or from left to right. So for example, if you want to look at some members in the tables, you can either find them in the tables yourself, or you can just click on the beam or member in the structure, and the tables will be synchronized and automatically show the information. Similar it is with the node information. If you want to know the coordinates of a node, you just click on one and the table will automatically jump to the corresponding nodes. At the same time, you can double click on a node and you see the node coordination the node coordinates right there. Or you can, if you want to manipulate or change something, you just use the context menu on the right mouse key, and all the relevant commands will show up there easily. But I don't want to go in too many details. I'd like to hand over the control now to my colleague Chelsea Jennings, who will show you the software in more detail and live. Chelsea, are you ready?
I'm ready. Hello, everybody. I would also like to thank you for joining us today for this webinar. As Walter said, my name is Chelsea Jennings, and today I will be doing a demonstration of modeling a steel structure in RFEM, followed by the analysis and design according to the Eurocode using our add-on module Steel EC3. And actually, I will be modeling the exact structure that you just saw on Walter's screen. Now I'm happy to begin modeling the structure. As Walter said, you can use either the navigation tree or the table at the bottom or the actual graphical window to input data. You can use one exclusively, or you can make use of them in a combination, which is what I usually do when I'm using the software. And really, it's about what you're comfortable working with. So to start, I can use, for example, the table here at the bottom to enter in a couple of coordinates for nodes, which will be the starting and ending point of my first beam. And I entered that here in the node section, and then if I click on the line tab, I can enter those two nodes and create a line between them. And now to assign a cross-section to this line, I can, for example, use the toolbar, and in this dialog box I can define the cross-section, and here I'm in our cross-section library, which is very expansive. And I will select this cross-section. And now I would like to create 3 more columns for this first section. And what I can do is I can copy this using our rotate tool and create 3 copies rotated around the z-axis. And there we have them. And for the next, next step, I will add bracing in between these beams, and I can use the existing nodes that I created. Select IPE, okay, and I can assign member releases. I'll just use the default setting. Here you can set your parameters for your degrees of freedom, and also for the end of the member. And I can just graphically snap in that new member. And once more, I'll do some diagonal bracing with L members. And okay, put them as tension and snap them in. And now to apply this bracing to all four sides, again, I can use the rotate tool, which will automatically have your previous settings saved when you open it. And here's the lower section of our tower. I can create two more exact copies using the move tool, and I want them to be directly above this, so the height of the section will be the displacement. So if I zoom out a little, here we have the tower section of our structure. And at any time, at any point, either in the table here at the bottom, you can make adjustments to something you've previously entered. I will use, I want to lower these and make this top section a little smaller, so I can also edit it this way. So I move these down a little bit. Okay. And now this tower is going to be supporting some kind of tank or container at the top. And so I would like to enter in a few members to support this container. So what I can do is I can divide these members. We have three options for dividing. Graphically, just picking a point in the display, or setting a number of intermediate nodes, or defining it by distance. I want these to be equally divided, so I will just use intermediate nodes. And here you can see where each was 1, now there are 3 equal members, which now these new nodes will allow me to enter in the supporting, actually I'll use one that I've already defined. All of the cross sections that you've previously used are here available for you for easy access. And once more, rotate around, and you can see the top of this has support. Okay, and now the second part of this structure is going to be a platform. I want the support, or the base of this platform, to be in the same layout or style as this. So what I can do is I can copy these members, and using control, holding control and just dragging and dropping them, now I have the base for my platform. But I would like to extend it out further, so maybe if I adjust my grid here for some guidance, I can select these end members, and whatever is attached to them will, I think that's where I want it, yep, will adjust automatically. So you can easily make adjustments to something that's already entered. Okay, and now the platform, I would like it to be in a grid layout. And we have a great tool for doing grids. And I will use this member here as my starting point for the grid, and select extrude member into grid. And in this dialog box, you can set the material and your distance, which direction was set to X, which is perfect, and also the number of parallel and perpendicular member divisions that you want. So, and here's your preview of what is going to be created. And now I can zoom in and show you the generated grid. And the last thing that we should do for the structure is support it. And I will place a few nodal supports at these 6 nodes here. So I can select nodal support, and here you have your options for your degrees of freedom. The default settings are fine for a column support, and now I can just select these nodes Now I have completed the modeling portion of this demonstration, and we have our structure ready to go for loading.
Yeah, Chelsea, thank you for this first part. We've seen how easy it is to use the software, the graphical way, the intuitive way of how to model and create structures, and how we can use the copy and rotate features. And also there are special features like this grid generator that makes it very easy to automatically create typical structures that are used in today's civil engineering and construction. Especially the drag and drop features, the copying, rotating, zooming in, zooming out features make the tool really a very powerful graphical modeling program, and many users value this the most, that you see everything immediately, and when you do something wrong you right away see it visually and you get a real impression of the 3D structure. Next, what we are going to do now is continue with creating some load cases and some enter some loads, some point loads, some area loads, but there is many things, many different load types, including temperature loads and imposed displacements and variable load types inside this program. We are using just a few basic tools today to demonstrate the general procedure how to design such a steel structure. And I give the control back to Chelsea, where she can then continue with this presentation. Chelsea?
Yes. Okay. So now I would like to add the loads, and I can do that from the navigation tree here. Create a new load case. By default, your first load case is considering the self-weight. So we just need to add a name, and we have that set. And going in from the toolbar, just the different input options, we can assign our first live load. As I said, this is a container at the top. And for the container load, I will just add new member loads to those 4 supporting members at the top. If I go into the Z view, and turn off this, there we go, I can, it'll help me select the member loads. Here you define the magnitude of your load. I'm going to have a concentrated load in the center of these members. And just select them. You can see the loads right away. You can also turn off the numerical values or the load themselves. The display is up to you. Creating our second load, our second live load will be the platform. And for this I will use one of our load generation tools. We have several here, including wind loads and snow loads according to Eurocode. These are very great tools. For this example, I will not be demonstrating these. The structure can be inside of a plan and not experience these loads. I will be using area load converted to member loads. In this dialog box, again, the magnitude, and you can see here it's automatically selected this group of members, but I can just show you how to select. You just click around one at each corner, and that's selecting where to apply the load. And the thing about our, this is some output data about what was generated. So here again, you can turn off the numerical values. The great thing about all of the load generation tools is that they are tied directly to the geometry of the structure. So if you make I'll turn off the load here, if you make an adjustment to the geometry, for example, if I extend this out, the loads will automatically be regenerated and adapt to the new geometry, which is very nice, and you don't have to think about resetting those if you make changes along the way. Click back to my original settings. Okay. So here we have our 3 load cases, and we are ready to generate load groups and combinations for our analysis and design. And for that, we will use RFEM. This add-on module is a load group generator based purely off of our available international standards and, in addition, national annexes that you see listed here. And here you can make your parameters for which to generate. And in this tab, we will define actions. Again, by default, the first action is the self-weight. So creating our second action, which will be live load, and we'll just apply both of those. And in the next table, we have the action categories, and we just assign the appropriate actions to the categories. And this example is fairly simple with just 3 load cases, but this is a very useful tool when you have many load cases, for example, including seismic, wind load, snow load, as you can see. Okay, if we just run the calculation, we have here our results, which are our load groups. And you have the choice if you want to apply or consider these load groups and apply them to the main program. I'll go ahead and export all 4 back to the main program. And here we have our 3 load cases, our 4 load groups, and our load combination. And you can click through them. If you turn the numbers on, you can see it's not so clear in this view. But you get the idea. And so now I can go ahead and run through, calculate all, and get our first results to begin the design process. And I believe I'm going to hand it over to Walter now.
Thank you, Chelsea. We've seen the creation of the loads, and one special feature actually that you can place a concentrated load at any part of the member without creating a node there. That is not common for all software. Or also this area load converter that converts automatically area loads into member loads, and also is updated after structure changes. One thing I'd like to point out is that Chelsea created load groups. Load groups are actually what you might know better as load combinations from code or other programs. And there was another quote load combination that we create in our name, and this includes the maximum and minimum forces or results of the analyzed load group. So we also have things like an envelope load combination that we do as in our software. It's called load combination. The results or the analysis can be done according to first order, second order, or large deflection analysis. So you are able to include p-delta effects in this analysis, and if you need to, you can also use objects like cables for cable stay towers or guide towers that you can analyze, and just as we have seen, model it as a regular member, and you will be following the cable theory for analysis of those members. The next part we are going to do is we are stepping into the design module for steel. It's called Steel EC3, where we we'll see how we design a part of the structure. We'll do the ultimate limit state design, but the module is also capable of doing, for example, stainless steel or fire checks for safety against fire. And it has a lot of buttons, a lot of functions, a lot of details in the module, and we'll point out the most important ones for you. And I ask Chelsea to continue with her presentation now.
Great, thank you. Yes, so going back into the data navigation tree, I will just turn off the results first and the loads. And the purpose of this design, our focus of this design is going to be to optimize the cross-sections used in this platform. So if you're focusing on one specific section of a structure, it can be helpful to create what we call named partial views. And I'll just create one here of the platform. So you select what you want to include, create a named partial view, call it platform. And so now you have the option to at any point turn on or off this view, which just helps you get a cleaner look of what you're focusing on. Okay, so now I can open up our add-on module, Steel EC3. As Walter said, it's the steel design according to Eurocode, and we have available ultimate limit state design, serviceability limit state, and fire resistance design. And in this add-on module, as is common for all of our add-on modules, it has the same basic layout as you can see as the main program, with the navigation tree on the left, which will guide you through the different tables of input and also of results once we run the calculation. So to begin, by default, the members that are selected for design is all. But as I said, we just want to focus on the platform. So I clear, and here's where this view is handy. And select our combination for design. In the Materials tab, by default, it is exported or imported, from RFEM, the current material that's in use. So you don't have to actually enter this in. And here you just have some material properties for reference. In the cross-sections tab, you can see all the cross-sections that are used in the structure. Here, these two have the remark 7 that no member of this cross-section is selected for design, which is accurate because we are specifically concentrating on these IPE 330 sections. And as you can see, we have lateral intermediate supports. You can adjust if necessary, or if you're working with columns at effective lengths. And here I see fire resistance members. So that means that I accidentally selected for the wrong instance. So I want ultimate limit state. And when you don't have fire resistance, anything selected for fire resistance or serviceability, you don't see them in this tree. Okay, so now I'm ready to run the calculation and get our design ratios. Here, as you can see, the results have appeared in the navigation tree, and we have the results, or the design by load case, by cross-section, by member, and by X location. And over here you can see detailed description of each check every step of the way, what the check actually is, and where it's referencing from in the code, which is great when you want to see how the design is being done and what is actually being checked. You can very easily access everything and reference it in the code. Okay, so as I said, we want to optimize these cross sections. So just going back to this table, we can select optimize because we have quite a low design ratio here and we would like something a little bit more effective. So running the calculation once more, the program now is going through our cross-section database, or cross-section library as we call it, and picking out the most effective section based on any parameters that we set. And in addition, in the Details tab, you have access to more options for serviceability, stability, fire resistance, and in other, you can adjust what results you want to be displayed. You can just select design of welds, slenderness, and also you can adjust your allowable design ratio. So here we have our new design ratio back in the results tables where I am. And if you go to cross-section, here you can see your original section that you had, and here is your result from the optimization, the suggested cross-section. And we can export this back to RFEM and automatically have it input into the model. And going back, let's see, go ahead and display all. So here we have, you can see this little info drop down, the IPE 220. And we can run through all calculations once more and get our final results, and I can go through the different options for displaying results, which we have very many options for this, and it's fully customizable. So here you can see deformations. These orange lines are deformations, and they can be displayed a few different ways. First, I'll show you that you can go through your different load cases, load combinations here, and automatically see the results. And so, as I said, the deformations can be displayed as lines, or let's see, go into my, here we go, deformation, or as rendered cross sections, or also as cross sections with the color scale, as you see here on the right. And this scale can be adjusted. You can set a higher minimum, for example, or if you want to show maybe just these lower two parts of the tower, the max will automatically adjust based on the max for that section that you have selected. And going back to choose one of our load groups here. Going back to the deformation lines, for example, you can edit the factor for display. Okay, and you also have in your results tab here, the navigator, you can display for the members' internal forces, your axial forces. You can also turn off the rendering of the cross sections and show a line model, which can be nice in your results. So yes, you can show your axial results, shear, and bending moments. And again, this can be, the scale of this can be adjusted here on the right with these options. In addition, you can show also your results from the add-on modules that you use. For example, here's our steel results. This is our max design ratio. You can show it like this. You can go ahead maybe and put our named partial view back. And you can turn off the hidden objects, as you see, if they're faded in this view, or you can hide them altogether. So you can show your results in this way, or maybe it would be nice to show them just on each member, the design ratio, and another option for display is to turn on colored options, which maybe helps you quickly orientate yourself with the section. And if you have a view that you like and would like to include into your printout report, you can just easily print it using the print option. It prints, here I have selected as screen view, so this will be the exact image that will be transported to the printout report. And you can adjust the size here, or also from within the report you can make adjustments to the size and the pictures also. So here you have the printout report. As you can see, you can have a lot of data included, from the geometry, load cases, load groups, and results. And again, the results from Steel or any of the add-on modules that you're using. Here we have our results from Combi. And you can choose which data to include, which not. It can be customized in every way to what your needs are. So there you go, and just going back to nice view, turn this off. I would like to thank you for your attention, and I hope it was interesting. And
I guess I have
would like to thank you and hope that you'll be joining us for another one. And I'm done, and now back to Walter.
Thank you, Chelsea. She's been working very hard to make this presentation, so I think it was very, very well done. I have some questions that are coming in, and one question was before already if we can do this grid tool also for different materials. So it's possible to do this also for any other materials, timber, concrete, steel, it doesn't matter. If Chelsea, if you would give me the mouse control, I could maybe show it directly in the program.
Okay, you should be able to take over.
Okay. I can't do it now, but shouldn't be a problem. Anyway, I see some other questions coming in. One question is, the results are displayed with 2 decimal values. Can it be adjusted? This is also possible. Maybe I just go ahead and show it on my computer. Hang on. What you can do, if you have here the results, you go into the options, display properties, and edit it, and there you find a lot of settings that you can change. For example, you have the same structure again, like structural loads, results. First we talk about colors, then we talk about fonts, and then here's results, and then you can here find the result values, deformation sections, internal forces, and you can change, for example, the colors. And hang on, results, members, internal forces. Here we have the colors and the decimal. I'm sorry, it's in the wrong. This is the colors, but I need to go actually to the units, and it's also a strong feature. So here you can set up the colors and all the fonts and so on, but we need units, and the units control how many digits after the comma you can see, and you can get it, for example, by right mouse click in the data navigator to the structure, and in units and decimal places you can find the results, and in the results you can see, for example, member, support and internal forces, and we switch it to 1, and then if I apply the change, it should change automatically to just 1 digit after the comma. So here you can also change the unit in general for each module, for each result type, and once you are done, you can save it as a new profile and make it as a default situation, and then you are done actually for your next project, and you don't have to set up again. So this was one question. One question is, can we design steel tubular tower of 80 meters, 90 meter or 100 meter height in this program? I do not see any reason why not. You just need to model the structure as we see in here. You need to have instead of I sections, you choose some other type of cross section from the library. We have here I-beams, we have here hollow sections. You can even put in your own design, own geometry of the hollow sections, and if you have done the loads and the model and the combinations, the Eurocode module will also design the hollow structural sections, and the type of the model, or the type, if it's a tower or a building or some crane or whatever, it doesn't matter. You have it's a general program. Circular shells. We can also, there's a question, modeling of steel tubular tower, is it possible using circular shells? I mean for wind turbine towers? Yes, you can do that too. We can model a combination of shell structures and member-based structures, and it can be also of different materials. So you can, if you want to, you can also, for example, model the concrete foundation and then put on top of it a steel tower, and you have some, maybe some container or some blades of a wind turbine on there. In principle, it is possible to model and combine all those object types. Of course, it is not so simply to do a moving structure like a wind tower, but we have, especially from the new renewable energy area, a lot of customers that use our software. Okay, a couple more questions. How to model welded connection of two members welded one on top of other on its flange. I'm sorry, but I cannot do it just now on the spot in this model. Maybe this would be a topic for another webinar. It is possible to do connections in there with contact and solid elements, but it cannot be answered now within like 2 seconds. But maybe if you send me an email, I'll be able to send you some examples where we have done it. Another reference video. Do you have another reference video or document case study for tubular tower modeling and analysis and design? There are some videos actually on our website that show how to build up towers. Especially also we have tower modules that are parametric, that show parametrically how to build up towers, and I think those would be very helpful. And I think also this could be part of another webinar. Maybe again also send us just an email with your request, what you like to see, and we can maybe give you a one-to-one demo for this specific structure you'd like to see. Then there is another question, can I design a tapered welded I-section with the EC module? And yes, you can. You can do this. Actually, we have it with the general method inside the Eurocode module. If I go back to the details, you can select whether you want to use the general. Hang on. This is maybe not in here, but in the national annex. And you can use the general method, which allows also for for tapered sections, or we have updated the software recently with a new method according to a research done by Naumers, Feldman and Sedlacek that allows for a general method for double bending, also for a wider range of cross sections. So with either this option or with the general method, you can do this design. For concrete structures, there's another question. We will do an webinar next week, and maybe you join this webinar and we will deal then with concrete. And last question maybe, ASE chapter in combi module. Do we have also possibility to prepare UBC combinations with this module? We have the, let me go back and show you. We have the AISC combination rules in here, and I show you. And here you can use the AICE 7 combination rules that are mostly basis of all the AISC design, and things change then, and you have different actions as they are in this code. And if you should not really be able to use this specific code, what you always can do is you can create your own combinations within RFEM itself. So it's always possible to make your own group or edit your group, and you can always add in here additional load factors that allow you to hang on, I made a typo here, that allows you to work with it. So any load combination you can actually do, and you can also save them as a new scheme, combination scheme. So in future, if you would like to have use of those combinations again, you just save your set of combinations, and you basically load it into your new project. Okay. I guess there are coming more questions in, and I keep on going. As long as you're staying with us, I'm pleased to answer them. So there was another question about fatigue analysis. At this moment, we do not offer a straight module for full fatigue design, but we have a module called RF Steel, not RF Steel EC3, but RF Steel. And in this module, you can get things like stress ranges, so you can analyze a set of different loading types, and you get the maximum and minimum stress in each stress point. And with this range, you can continue to do your fatigue analysis. Or what some customers have done also, we have a programmable COM interface that allows to get access through an API, or like Excel, for example. You can export into Excel, and you can then do other checks and continuous analysis for other problems you might see and or need in your company. So it's open, so we can do this. Dynamic and eigenvalue analysis, it's all possible in RF Dynam. We have here eigenvectors, we have here time history analysis, response spectra analysis, equivalent load procedure, and it's also all according to DIN or Eurocode or IBC. So there is other codes here that you can use, and with the response spectra method, you are actually absolutely free in your code, because you can create your own response spectra as you like it, as you have it in your code, and that should match basically all the codes. Export structures into DWG format. We can export it. There is a lot of things for CAD. We can import and export the structures to different formats: DSTB format, DXF format, IFC format, and the DWG would be basically a new option that we have. We gained it through an interface to the ISM as an integrated structural modeling from Bentley, and with this you can export it to a viewer, basically synchronizer, that you can download for free from the Bentley website, and then you create a DGN file, and with this DGN file you can import this in AutoCAD, and then you have also the real cross-section information in this DWG file. And of course we can export the DXF file of this structure here, but since we are working with member-based structures only, we only get the center lines. We want actually to see maybe the real cross-sections, and with going through ISM and DGN file, you can actually also get this. Okay. Grain girder with box section and rail as asymmetric position. We have a grain girder program that tackles basic grain girder grainway structures, and it will open basically as a new model here, and you can analyze grainway structures, but they are only for I-section at the moment. If you have box section and asymmetric rail position and so on, we would have to do a modeling as a surface element or a shell model inside RFEM, and then you could do it. But it's not. It's basic work in RFEM, but it's not a special module. Exporting to AutoCAD is done using the DXF file, as I said before, and you can export it to a DXF file and open it in any AutoCAD version, AutoCAD 2010, 2012, or any other CAD application that can read DXF files. Okay, that were all the questions actually that have been come into the presentation, and I thank you for your attendance once more time. Thank you also for spending the time with us and looking at the software. As I said, please feel free to send us more feedback and more information to info@dlubal.com. Visit our website where you can find videos, manuals, and customer projects. If you'd like to see videos, maybe best thing is to go to YouTube and search for Dlubal software. And if you have any question later or tomorrow or next week, let us know. And I hope to see you on one of our next webinars again. And yeah, this will end our webinar. Have a nice afternoon and see you soon again. Bye-bye.